For the most part, this is amazing. This gives us speed. There's no inter-process overhead for communication. But it can be problematic in the context of a Rails application, or really any application where you have multiple workers. Because when you are dealing with and contending with Ruby's global interpreter lock, or global VM lock, you need to ensure that you can tell Ruby when you are waiting for non-Ruby work, non-Ruby I/O to happen, so that Ruby can pass the VM lock to another worker and it can do Ruby execution while the computer is doing non-Ruby execution elsewhere. But its I/O is embedded into the Ruby process. And so Ruby does not naturally have awareness of the fact that actually no Ruby code is executing, SQLite C code is executing. And so Ruby will just hold the VM lock on a worker as it waits for SQLite to finish and to just find the right lock and run.
Let's start the day. Our first speaker. Should I tell them what your title is right now? So my friend Yaro said now that his title is SQLite Jesus. So he's here to talk about SQLite on Rails and how easy it is to. Actually, I'll let him talk about it because I don't want to ruin it or anything. Give it up for Steven.
This should be a pretty straightforward talk. I have somewhere in the range of 30 to an hour and a half, 30 minutes to an hour and a half, we'll see, to just tell you everything you need to know about SQLite on Rails. How hard could it possibly be? But I don't want it to lean towards an hour and a half, so let's jump into it. I mean, what can I do? My name is Steven, as Adrian said. I go by Fractaled Mind on Twitter. My day job is being a full-stack engineer at a company called Prevail Legal. They do deposition management software for law firms. But what I want to talk about today is my open source work. I am the maintainer of and contributor to a number of gems in the Rails ecosystem. And along the way, I write a fair bit on my GitHub Pages blog. And somehow, over these last 2 years, I have become a top 400 contributor to Rails all time. And I don't know how actually that happened. But it's pretty mind-blowing. And looking back, a lot of that activity has centered around one particular theme, which is making Ruby on Rails the single best web framework in the world for building simple yet powerful applications. And in my experience, it is my hypothesis that leaning heavily on SQLite as a database engine unlocks the potential for building radically simple yet fully powerful applications. And that's what I want to talk about with you all today. Now, inevitably, when I suggest you should use SQLite, hell, you should go all in on SQLite, I get the question, why? Why would you do that? Why in the hell would I do that? You know, SQLite is supposed to just be for toy applications or for running your local tests faster. And sure, it's useful in those cases. And there is some foundations to this question. And I try to take it seriously. So I'm going to begin by giving you my answer for why I have used it in real production applications at work and evangelize it. Fundamentally, one of the things that I respect and love most about Rails is this philosophy. Rails is aiming to be the one-person framework. It aims to be a bridge over complexity that allows the smallest possible team, right? You, on your laptop, in your house, doing everything on your own, to actually build full, rich, powerful, economically viable web applications. And that's a beautiful, to some degree, maybe radical vision that I believe SQLite uniquely and powerfully aligns with. The first reason why is that it is simple. The database is literally a file on your file system. The database engine is a single C file that runs embedded within your application process. You don't even have to spin up another process. And this simplicity unlocks some unique degrees of possibilities with your application we'll talk more about. But you need simplicity as a lever for opportunity when you are, as a small team or an individual, trying to do something, make a name in this world, make some money, as Tom was talking about, right? Like, simplicity is leverage. It also grants you control. When the database is a file on disk, when the executable is embedded in your application process, this gives you unique degrees of control. So firstly, naturally, the configuration for everything to do with your database just lives in your monolith. Everything lives in your monolith. There's no other process. There's no fancy other server. It just sits right there. So everything gets version controlled. Everything is clear and accessible to you. Like, what are we doing with this database? How are we setting it up? It also unlocks some interesting developer experience opportunities. We'll talk a bit near the end about how you can take advantage of the fact that your database is a file on disk to connect your database with your Git branches and have a completely isolated database for every single Git branch that you're on. Forget about conflicts as you're working across the team. You have unique power and control over the tool that you are using and the database that's backing your persistent data. And then, of course, it's fast. It's hard to really appreciate how fast it is and how much of a difference it makes until you try it. So I do hope that you try it and really internalize for yourself what it means and what it feels like to have your queries go from being measured in milliseconds to microseconds. Write simple queries. You don't have to compose these massive select statements necessarily. Sometimes you do, but you don't have to. Like, you can just make 100 small, simple reads and aggregate the data on the Ruby side, because you're not going to pay the penalty of sending an electron over cables under the ocean to the AWS data center in Virginia. So my primary goal for today is to make everyone feel comfortable and confident that you could run and build a SQLite on Rails application tomorrow. So how? How do we do it? How do we build, run, maintain a full-featured Rails application leaning on SQLite? And here I have to be honest with you. The fact of the matter is that running SQLite on Rails today, out of the box, is not viable. And this truth is the foundational reality that has driven a lot of the sort of general sense that SQLite is not a production-ready database. The fact of the matter is that the authors of SQLite, the maintainers of SQLite, care far more about backwards compatibility than they do about enabling the features that they build by default. And so SQLite in particular as a database requires you to tune it. You have to tune its configuration, you have to tune its usage. And if you don't, in the context of a web application, things won't work naturally out of the box. So what we're going to talk about today is, what do you have to do to configure SQLite and to use SQLite such that you don't experience pain. So for all of the people who, like me, are 15% hungover and you're coming in and out of your ability to pay attention, no judgment, I get it. Here's the moment, pay attention, take a picture of this slide. This will solve all of your problems. This is magic. Now, for the people who pulled their phones up and are scanning the QR code, we're going to have fun in the next few minutes. Because this is a brand new gem script item, open source gift that I am very happy and excited to unveil to the world today in front of you all live. And it is really the culmination of all of the work I have done over the last 2 years. And for those of you who might follow me, I've been trying to figure out, like, how do I want to take all of this effort, all of this expertise that I have stumbled into over the last year, packed into this script to make it a simple one-liner to get an application created and scaffolded that is ready to go out of the box. I've been chatting with people on Twitter, trying to find, like, what is the most reasonable path forward? Because, open source sustainability is a topic of conversation. We had a panel about it at Euroko last week, and I'm trying to figure it out myself. And, I got a lot of people saying it, not quite this, here's some suggestions, and I've been meditating on it for a while. And so I want to also explain to you my reasoning for how this tool is going to be made available to the community. So after much consideration, I just decided to make it free. And there's two main reasons. We're going to get into them more. The first reason is that I have also been lucky, a lot of those commits into Rails, to drive almost all of these features into Rails itself. And so when Rails 8 is released, about 75% of this script will be unnecessary. Because when you run Rails new without using this template script, you're going to get all of the things you need. And I'm going to go into more detail about what those are. And the second reason is that I really genuinely want to give as many people as possible the opportunity to take advantage of this leverage, to build something, to try something, to run experiments, right? To try your hand at doing something in the wider internet economic world. But if you've tried to access the URL on GitHub, you will see it is a 404. Because I haven't released it, and I thought, let's release it now. So this is the GitHub repository, and I need to make it public. Change visibility. Change to public. I want to make this repository public. I have read and understand these effects. Now I will type. You can copy and paste. Don't worry, I'm both fast and correct in my typing. GitHub Mobile, security first. Let's pull this up. A little dialogue. Okay, I need to open the app after I click the button. So close, reopen, type it in, wait, continue waiting, suspense. Okay, there we go. So now, you can visit the URL from the slide that you all took pictures of, and you can actually see the code. The README is, relatively extensive as well, so feel free to go in there. It is a configurable script. I walk through everything that it does and all the different configuration options. I'm not going to do all of that now. What I'm going to do instead is walk you through the key details of what it does. So this is enlightenment. This is the script that is going to walk you down the path to SQLite enlightenment. And it does that by doing 6 things for you. It is going to ensure that every single SQLite connection that your Rails app spins up is configured for optimal performance. It's going to set up solid queue, solid cache, and solid cable so that you can back all of the core active or Rails components that require some form of persistent data with separate SQLite databases so that you don't need to spin up a Redis server or spin Redis up on your server. You can go all in on SQLite. It's then going to get Lightstream set up so that you have a data backup procedure in place. And we're going to talk more about all the tools that are available there. And then finally, and optionally, all of this is optional, but by default, it's going to install and set up another gem that I have built, sort of inspired by the solid gems, solid errors, which is a local error monitoring tool. So free, simple, basic, sort of on-ramp to something like Honeybadger, where maybe on day 0, you don't want to set up all of the extra stuff in the extra service, but I do think that having error monitoring is valuable and important to have on day 0, and so why not just sit a SQLite database on your server and pump errors there and put a little Rails engine available to you. So we'll get into all of that. Let's walk through these key points. So how does it configure your SQLite connections for optimal performance? First key point, when I say optimal performance, that is a very relative term because even without any tweaking, like SQLite is indeed crazy fast. This is a comparison of SQLite queries to Postgres in 4 different configurations. And you'll see like even when you're running Postgres on the same machine as your application, just the inter-process overhead means that SQLite is about 10 times faster than Postgres. And of course, if you're using something like a cloud-managed database provider and you have your database deployed into multiple regions, like definitionally, multiple of your application instances are going to have to make cross-region requests to your database. And in that case, you'll see SQLite is somewhere in the range of 500 to 1,000 times faster. So we're talking about optimizing it inside of already a very fast performance profile, but nonetheless, it is important to optimize it. And the first reason why is that while it is fast, in the context of a Rails application, if you don't do any configuration, you're going to see errors. So it doesn't really matter how fast your database is if your web app responds to users by saying, I don't know how to respond to your request. In fact, if you run some load tests, you'll see that as the number of concurrent requests increase, your percentage of errored responses increases. And in my simple load test here, you'll see even at just 4 concurrent requests, and I was running the application in production mode with 10 Puma workers, so I'm not even at like half the number of Puma workers I have spun up. I'm almost at 50% error rate. So clearly like completely untenable for production. And beyond that, you do see problems with your long tail latency. And so for like once you cross that Puma worker divide and you have more concurrent requests than you do Puma workers, without any configuration, the out-of-the-box experience, you will see your P99 and then eventually your P95 skyrocket. 5+ second requests also not really tenable for production. So yes, SQLite is fast, but in the context of a Rails application without some configuration, you are going to hit some very real hard edges. So how do we solve them? There are 4 keys to solving this problem. If you want to go into more detail, like I'm not going to take an hour and a half, I'll only take an hour and 15. These are the 4 steps. That was a joke. Don't worry, I won't take that long. I have a whole blog post, walks through every single detail. I'm going to give you the highlights here, but if you want to go into more depth, the blog post really covers everything. But there are 4 keys that we need. So the first one is write-ahead logging. This allows you to have concurrent readers with your writer, and it will massively increase your performance. The nice thing is, this is already done. Since Rails 7.1, this is default in Rails. Rails will ensure that all of your SQLite databases are spun up in write-ahead logging mode, and so you don't have to do anything. That is there. Performance gained. When it comes to the other 3, they're not there in Rails 7.1. We're going to have to do something about that. Let's talk about what the problems are and how we solve them. How we solve them, actually super easy. Here's another gem. It's not quite as poetically named as Enlightenment. This is the Active Record Enhanced SQLite 3 adapter. Okay, maybe it is poetic actually when it sort of rolls off the tongue. But this gem will automatically configure everything for you. So you just run bundle add, Active Record Enhanced SQLite 3 adapter, and you're good to go. That's what the script does. The first step is just adding this gem, and the gem will automatically register itself as a rail tie and get everything configured for you. What it's doing is when you are in these contexts, you have multiple concurrent requests. It's solving those two problems we saw by dealing with the core issue. The core issue, when you look at the errors, you see that SQLite 3 busy exception. Just stick there for a little bit. This busy exception, which is, for those of us who have been running SQLite in production, like if you, like me, have been doing it for a while, like this is the bane of your existence and plagues you, or did plague you for much time. The problem here, short version, is that the default way that SQLite handles transactions, so you have a transaction, something like this. When you run this, SQLite is not going to attempt to acquire the write lock. It only allows a single writer to occur at a time. And so it has a lock that it is passing between different connections to say who is allowed to write next. In transactions, it doesn't attempt to acquire the write lock until a write operation inside of that transaction is seen. And what that means is if you run this transaction, step 1, step 2, step 3, attempt to acquire the write lock, and another connection is currently writing, because you're inside of a transaction, SQLite immediately the dangers of gesticulation, immediately errors, because it can't retry the operation because it might get a different snapshot from the database, and it wants to keep data consistency guaranteed. So what we need is we need to tell SQLite, hey, this transaction, I'm going to write. And so give me the write lock now when I'm taking a snapshot of the data, so that if I need to retry, I can retry here and not inside of the transaction. So before I get the snapshot, I could just wait my turn. Okay, now I have the write lock, everything's good to go. So that's what we need to do. Luckily, it's quite simple to do in Rails applications because you can pass this configuration from your database YAML straight into the SQLite 3 gem. And this is precisely what the gem is doing for you on your behalf. So you could do this in your app yourself, or you can just bring in the gem, but that's the problem it's solving, and that's how it solves it. As for the results, this was before we added that line to database YAML, and this is after. So that's a solution to a problem. Now, we do see 1% of errors 1% of requests are still erroring at 16 requests. This is because of our second set of problems. We do get timeouts. But for this problem, you're not going to have it with Rails 8. So the gem is there. You can use it today. It'll solve this problem for you today. But in, 2 weeks, a month, something like that, I imagine Rails 8 is around the corner. When you run Rails new with the Rails 8 application, you'll be good to go. For the next two problems, again, we see this long tail latency issue here. And that 5,000 milliseconds should ring a bell. We have this timeout in our database YAML. The contrast is, in the original slides, there's a little bit of an partial opacity filter over the rest of the database YAML that you can't see. So, oops, context lost. Imagine you're looking at a database YAML file and you see timeout 5,000. The issue here is that this particular configuration variable is going to be passed into SQLite to set this SQLite configuration option. SQLite uses configuration through pragma statements. This is problematic because of the way that SQLite and Ruby both work and the way that they work together. So SQLite is an embedded database. That means that it runs inside of the process and thread that your application has spawned. And for the most part, this is amazing. This gives us speed. There's no inter-process overhead for communication. But it can be problematic in the context of a Rails application, or really any application where you have multiple workers. Because when you are dealing with and contending with Ruby's global interpreter lock, or global VM lock, you need to ensure that you can tell Ruby when you are waiting for non-Ruby work, non-Ruby I/O to happen, so that Ruby can pass the VM lock to another worker, and it can do Ruby execution while the computer is doing non-Ruby execution elsewhere. But its I/O is embedded into the Ruby process. And so Ruby does not naturally have awareness of the fact that actually no Ruby code is executing, SQLite C code is executing. And so Ruby will just hold the VM lock on a worker as it waits for SQLite to finish and to just find the right lock and run. So what we have is this problem where worker threads are blocking each other even as there is SQLite I/O that's going on. What we need is this. We need to tell Ruby the difference between Ruby execution and SQLite execution so that Ruby can pass the GVL amongst the different Puma workers, and SQLite can do its thing. Everything is happening linearly, but we're mixing them, right? This is true concurrency. How do we do it? Well, we have this pull request into the SQLite 3 Ruby gem. The basic sort of solution here is to re-implement the busy timeout in Ruby so that we can use the Ruby sleep command, which will pass the GVL. The enhanced adapter gem gets all of this set up for you. I'm not going to sort of walk through. You could do it yourself if you wanted to. I did a workshop at Euroko. You can find that GitHub repository. It's Euroko-2024. And I walk through, if you wanted to make this switch yourself, here's an initializer. You can monkey patch a private method in Active Record if you want. That's how you would do it. Or you can just use the gem, or you can wait till Rails 8. Either way, it will completely solve your problem. This is what the latency looks like after the fact, and I want to make sure that we're noting here, this is P99.99, and even in the very worst, slowest requests, you see it plateaus. It doesn't really go above 500 milliseconds. So this is a 1,000-time performance improvement for long-tail latency. So that's how you solve the performance issues with SQLite. All of this will be default in Rails 8, which is awesome. But for now, all you need is the enhanced adapter gem. So it's super simple either way. For you, that was like 6 months of my life, but that's what open source is all about. Let's talk now about the solid gems. For those of you who might not have heard, there is a new initiative in Rails to provide production-ready adapters for the data-bound components of Rails. This is really exciting, and Solid Q is written by Friendly.rb's very own Ruza Gutierrez, who's maybe somewhere. I can't see very well. There she is. So we have a local celebrity. These gems are really amazing. I've studied Solid Q's source code more than the others. If you ever want to build a Rails engine, I highly recommend just go and read that source code. There are a lot of really, really excellent patterns for building high-quality Rails engines inside of Solid Q. Let's talk a little bit about what we're doing here, what the script does for you to get these things set up. So I don't want to take an hour and a half, so I'm giving you the highlights. The key details here is that we're going to want to back each of these data-bound components with a separate SQLite database. And we do that so that we have parallelism. There's no conflict. So for one SQLite database, you can only have one write operation at a time. There's no conflict with the two SQLite databases. So you can be talking to Solid Q's database at the exact same time that you can be writing to Solid Q's database at the exact same time that you're writing to your primary database without any contention. In particular, the gem is also going to add mission control jobs so that you get a web dashboard for your background jobs, and it'll mount the engine. It does everything that you need. You can just run it, and it'll be set up. For Solid Cache, there's no web dashboard, but it's basically the same thing. We're going to define a new database. We'll call it cache. We'll make sure it's in your database YAML, install the gem, prepare the schema, and if you want to, this is another flag you can control. You can configure the cache to be true in development mode. You can also configure, do I want the database to just be in production? Do I want to use Solid Cache in all of my environments? These things are all up to you. These are configuration flags for the script. Solid Cable, same thing, even simpler, separate database. So if you go all in on SQLite, you're going to have at least 4 databases. When we get to Solidaires, you can get up to 5. In some apps, I have 7. Embrace the simplicity of just having a file on disk, right? Like just spin them up. There's not a lot of issue there, and it gives you much more concurrency and parallelism. Simplifies your life. In general, I really am a fan of this movement in Rails. I think this is one of the key ways in which Rails is really leveling up as the one-person framework. It's giving us default adapters for these core components of Rails that when you back with SQLite, you get operationally radical simplicity and conceptually radical simplicity, and that's the kind of leverage that allows a single developer to really do full-featured applications without hiring a team of 10 people. So awesome, awesome job by the Rails core team, of whom Rosa we have among us. We should all give her, like buy her a water or a coffee or something today. But if you want to wait, all of this will all be defaulted in Rails 8 as well. Like you can just run Rails new. I'm so excited for Rails 8. If you can't tell, I'm going to be talking about it at Rails World next week as well, sort of sharing this vision of how Rails 8 and SQLite together unlock some really awesome opportunities and potentials for individuals. But that's a different talk. I swore a blood oath that it would be a different talk, so I'm not going to say anything more about it. Let's talk about backups. Lightstream. Lightstream is my favorite tool for doing data backups. And one of the reasons why I included backups into this script is because data retention should be a day 0 concern. And I know this because for me, it was a week 5 concern. And I deleted my database on week 4. So don't do what I did. Do as I say, not as I do, as they say. The way that Lightstream works, it will listen, it'll spin up a separate process and just listen to all the databases you tell it to listen to. And anytime a change occurs, it'll just stream it to some S3 compatible bucket storage. So you can use S3 or DigitalOcean Spaces or Google Cloud, or you can even set up your own FTP server and just pipe it over there, whatever you really want. But it's very simple on the one hand, but it gives you point-in-time backups on the other, which I think is a very special sweet spot in sort of simplicity and power. In order to set it up, if you wanted to do it yourself, this is what the script will do for you. You just add the gem. Lightstream itself is a single Go executable, so I wrapped it up in a gem with precompiled binaries so you can get it through bundler straightforwardly. And you just run the installer. Simple. What the installer will do is going to create 2 files just really quickly so you understand what's going on. The first is config lightstream YAML. This is the actual configuration file for the Go executable. You tell it about all of the databases and you tell it about which S3 buckets you want them to be backed up to. You're going to see the environment variables here. That's because the second file is a Ruby initializer. So this will allow you to centralize all of your credentials in your Rails app. So the default suggestion here is to use Rails credentials. You can do whatever you'd like. But you can keep all of your credentials for your S3 buckets in Rails, tell the Ruby layer about them, and then the Ruby layer will pipe them to the Go layer. To run it, you can spin it up as a separate process, or you can use the Puma plugin. The Puma plugin, obviously the simplest, but if you get to a point where you want a little bit more fine-grained control, you can pull it out, set up a proc file, run it yourself. The generator is going to set up the Puma plugin. To restore a database, you just run this rake task. The gem provides rake tasks that mirror all of the commands that the Go executable provides, and it's all in the README. In addition to just setting up a backup system, though, I wanted to, for myself, having had the trauma of deleting a database and trying to recover it, set up some verification layer so that I could sleep soundly at night knowing, yeah, my backup system is actually running and running correctly, like I have backups that work. So the gem also ships with this background job, which will verify that your backups are working. So it does that by just throwing a single row into the table, waiting 10 seconds, running the restore command, opening up that file, and seeing if that row is there. And if all those things are true, then we know backups are working. When we restore, we get a real SQLite file. That SQLite file has fresh data within a window of 10 seconds. Everything is working. And you can queue that up with solid queue, run it at a recurring schedule. I run it like every night at 1 a.m. And so if you have error monitoring in place, which we'll get to shortly, if it fails, you'll get an email or however you are getting notified of errors to say, hey, we are trying to verify Lightstream and it went down, and you can go in and get that fixed with as much time as you set the recurring schedule on. And it's these kinds of extra niceties that I hope to keep exploring and adding to the Ruby gem so that we can build out the best possible experience in Ruby, building on top of the really awesome lower level utilities that are available in the open source ecosystem. It also comes with a little web dashboard to give you an overview of what the process is doing and what's going on, if that's useful to you as well. I think I skipped the slide where I show you what it looks like, but it just shows you all of the data that Lightstream gives. It's a very custom proprietary format with snapshots and generations, and I don't have time for all that. The key point is I'm trying to give you all of the information you need to do everything that you might want to do and to make smart decisions. Most importantly, though, you will have backups. You just go get a bucket somewhere, you put your credentials in, and you don't have to worry about losing your data, which is naturally something that is worth worrying about with SQLite because your data and your application live on the same machine, and if that machine goes down, you don't want your entire business to go down because you lost all of your customers. The final thing that it adds, solid errors. For me, I had this moment of revelation of using the other solid gems and recognizing, there's other bits of data that my Rails app has that I would love to see, and I guess I could just pipe it into a separate SQLite database, build a little set of views, and mount an engine. And solid errors is the first gem that I built sort of following that vision. So Rails provides us with an error subscriber. So I built an error subscriber that gets errors, writes them to a SQLite database, or any database. It's database agnostic like all of the solid gems, but this is a SQLite talk, so screw Postgres. This is one of the really beautiful things that I want us all to internalize so that we can start to explore this space together and all of our creativity can come to bear to figure out what else can we add? What are other kinds of data that is useful to a Rails application that we could sort of embrace the philosophy of the solid gems to provide a database-backed adapter to just store it and provide it back to us. So you have solid errors. Like I said, it's an on-ramp to something like Honeybadger. And the setup that the script does is just like all the others, right? We're going to create a separate database, install it, prepare it, mount the engine, and you're good to go. A little teaser. Here's the UI of the dashboard. This is looking at a particular error. There's also an index page. But, pretty full-featured for what it is. You get pretty highlighting. You can see the snippets of your backtrace, the bits of code. You can resolve errors. There's actually a lot of information available in Rails. So if you want a free day zero solution to error monitoring, feel free to use solid errors. As I said, the script is configurable. You can also configure it to just not install this or turn it on at all, whatever you want. And that is the path to SQLite enlightenment. I'm going to take 5 more minutes. Because I just want to throw a few more things out there that aren't in the script but are also really cool and worth saying. So here's my miscellaneous section. Part 1, explore this space with me. I'm working right now on another gem, solid metrics. You know what Rails provides? Instrumentation. You know what we could do? Pipe them into a database. You know what we could do with that database? Pipe it into a view. That would be cool. It would be cool. I met a guy at Ubrico. He's working on solid logging. Rails provides logging. If we do structured logging, we can put those logs in a database. If we have them in a database, we can build a view. If we have a view, we can do really interesting, powerful things with that. Day zero, free solutions. This is something I'm really excited about, and I would love for more of us to explore this space. And at one point next year to have this slide with 12 solid gems on there. I think this is a really awesome, valuable opportunity that could really make the one-person framework aspect of Rails truly powerful. So come explore this with me. This is what the current version of Solid Metrics looks like, right? I can just really easily get all of this information about active record queries. Let's talk about some more cool stuff. The enhanced adapter gem does not simply do performance optimizations. It also backports a number of active record features for the SQLite adapter that are present in some versions of Rails and not in others, so you can ensure that they're present in the version that you're using. It also allows you to install and make use of SQLite extensions. For those of you who might not know, there is a rich ecosystem of extensions for SQLite. So if you want UUIDs or ULIDs, or you want to work with geodata and longitude and latitude, you want to work with vectors and do nearest neighbor vector searches, there are extensions for all of those things. You can use the unofficial package manager for SQLite extensions, SQL package. Once again, it's a Go executable. Wrap it up in a precompiled binary gem. Make it easy to install through bundler. And then run this task. You get it directly embedded into your application, and then the enhanced adapter gem allows you to declare which extensions you want loaded just in your database YAML. Another cool feature. You can also, this isn't anything to do with the gem, just a bit of information for you. You can control the compilation of SQLite yourself through bundler. This is a feature that the SQLite 3 gem exposes. So if you want to eke out an extra 3% of performance, or you have some very specific needs and optimizations, you can run this. This is like the 6 optimization flags that I use in my application right now. But you can read all about the compilation flags that SQLite offers. And again, it's available to you through Ruby. There's not a ton of magic there. You can see what you're doing. It just lives in your repository naturally. Talked a little bit about database branching. I could give a 45-minute talk on this alone because it's incredibly powerful and cool. But I want to show you how simple it is to set up, right? So did you know that you can put ERB in your database YAML file? If you didn't, now you do. And did you know, you probably did, that of course ERB is just Ruby, so you can execute shell in Ruby with backticks. So it's pretty straightforward to just say what is my current branch? And say that's my database name. And then all you need to do is make sure that Rails will spin up that database and get it into a usable state. You can call the prepare task programmatically in Ruby. So set this up in your development environment. After initialize, this will make sure if the database file doesn't exist, it does exist. If it needs to run migrations or load the schema, it'll do that. If you have seeds, it'll seed it. So you can get a ready-to-use database there. And then once you have that, you can do some various other scripts. This is all in my workshop to actually move data between the databases. So if you have a bunch of data from your main database and you want to bring those rows and those rows for all of your tables into your feature 1 database, that's actually a pretty simple bash script. All of that is in the workshop if you want to check that out, Eurocode-2024. Whew, that was the speed through the miscellaneous section. Thank you for the extra 5 minutes. I really hope at this point that you're a little bit less hungover. I am. I also hope that you have a little bit more appreciation for how SQLite really is a powerful partner to Rails in unlocking the potential of the one-person framework. I agree with David that it is a beautiful tool and worth using. If you happen to really want to go deeper in this, just one small plug, I did write a book laying out everything I know, small ebook on Gumroad. To be honest, you could just use the script. It does 98% of everything I know is just embedded in the script. So if you don't care to know what's going on, you just want to build a Rails app, use the free script. If you appreciate the years of toil and labor, and you could throw me a bone, I guess. or just use the free script, whatever feels appropriate to you. Thank you.